All right, so today's class for algebraic problems, we are looking at distance problems. So we have covered distance problems a little bit in the previous unit that we were doing, where d equals rt, distance is d, r is rate, and then t stood for time. All right, so we're going to look at two types of distance problems. The first one is where we have distance A plus distance B is equal to total distance, or dt. So in these first kinds we'll look at, we'll have like two cars or planes or something like that. Either they're traveling towards each other or they will be traveling away from each other. So therefore, we will add their distances together to get the total distance of dt, shown here in the formula. All right, so let's take a look at our first example. There's a couple ways we can do these distance problems. The first method is you can set up a table and then just fill in the values from the word problem. So like situation 1, situation 2, you have your rate, time, and then distance, and you know that the distance is your rate multiplied by the time. Or you can use a diagram. All right, so let's take a look at our example, and it's done here showing a diagram. So our example is that Jet Jones left Montreal at 4 p.m. traveling west at 116 kilometers per hour. 1 hour later, 5 p.m., Barry Brown left Montreal traveling east at 84 kilometers per hour. At what time will they be 316 kilometers apart? All right, so in this situation, we are using dA plus dB is equal to total distance. So in this diagram, JJ here stands for Jet Jones. The BB stands for Barry Brown. So we can see from this diagram, here's the Montreal, and then here's Jet Jones traveling at a rate of 116 kilometers per hour. Time is what we are solving for. For Barry Brown, the rate is 84 kilometers per hour, but leaving an hour later, so we can see here the x minus 1. All right, so if we were to do that in the chart method, so you can just do, oh my goodness. So we would do rate. Something's not right, 1 second. Okay, so we would have the rate, the time, and the distance. I'm just doing a quick chart here. And then we have JJ and BB. So JJ is, the rate is 116, the time is x, so therefore the distance would be 116 times x, so 116x. And then for BB, the rate is 84, the time was x minus 1, so therefore multiplying these two, it would be 84 multiplied by the x minus 1. All right, and then we are told in the question, when will they be 316 kilometers apart? All right, so now we can go ahead and set up our equation. So our equation is dA plus dB equals dt. So therefore, 116 times x plus 84 multiplied by x minus 1 is equal to 316. All right, so from here, we're just going to multiply this out. 116x plus 84x minus 84 equals 316. So we'll add the 84. We can collect these two like terms together, which gives me 200x. And then we're going to add the 84 over, like so. So we get 200x is equal to 400. And then we'll just divide by 200 both sides, which gives me x is equal to 2, which is 2 hours, right? Because we are solving for a time, which we called x. So x is equal to 2 hours. So if we look back at equations here, So therefore, they will be 316 kilometers apart at 6 p.m. So final sentence here. All right, at 6 p.m. Or in 2 hours. Okay, next example. 2 cars left Hamilton at the same time, one traveling east and the other west. So here's Hamilton. We have one traveling east and the other west. Their average speeds differ by 5 kilometers per hour. After 2 hours, they are 210 kilometers apart. Find the speed of each car. So this time we are looking for the speed, so R. Okay, so what we know about their speeds is one is x, the other one is x plus 5 because their speeds are differing by 5 kilometers per hour. All right, and then time is 2 because it's after 2 hours that they are 210 kilometers apart. So again, in this situation, we're going to say that dA plus dB is equal to d total. All right, so r times t, this is going to be 2x plus dB, which is r times t, which is going to be 2 times the x plus 5. And that is equal to 210 kilometers. All right, so now we can just go ahead and solve this. So we have 2x plus 2x plus 10 equal to 210. So we have 4x here when we collect these two like terms, and then we can subtract the 10 from here. That gives me 4x is equal to 200. And then we're just going to divide by 4 to give us our x, which is 50 kilometers per hour. All right, so their speeds are therefore going to be 50 kilometers per hour, and then x plus 5, or 50 plus 5, which would be 55 kilometers per hour. All right, so their speeds are 50 kilometers per hour and 55 kilometers per hour. Okay, so just looking at our next one here, a bus and a car leave the same place and traveled in opposite directions. If the bus is traveling at 50 miles per hour and the car is traveling at 55 miles per hour, in how many hours will they be 210 miles apart? So distance here is r times t. So we have 50t plus 55t is equal to 210, and we're going to solve for t. All right, so we have here 50t plus 55t. That would be 105t is equal to 210. So we're just going to divide both sides by 105, and that gives me t is equal to 2. All right, so therefore, the question is asking in how many hours will they be 210 miles apart? So in 2 hours, they will be 210 miles apart. Right, so the next type of distance problems is the situation where distance A is equal to distance B. The rates and times for two vehicles are different, but the distance covered by each is exactly the same. All right, so in these instances, dA is equal to dB. So first example, a car leaves Ottawa traveling at 40 kilometers per hour. A second car leaves Ottawa 1 hour later and travels at 60 kilometers per hour. How far from Ottawa does the second car overtake the first? All right, so in these types of situations, we'll have dA is equal to dB, and remember that distance is equal to rate multiplied by time. All right, so our situation here, the first car is traveling at 40 kilometers per hour. Their time is x plus 1. The second car is traveling at 60 kilometers per hour. Their time is x. All right, so multiplying those out, so we have 40 times the x plus 1 is equal to 60 times x, which is just 60x. And here we would have 40x plus 40 is equal to 60x. All right, so we're used to bringing the x to the left side, so we'd subtract 60x, and at the same time, we're going to subtract 40 and bring it to this side. Okay, so we can see here that we end up with negative 20x is equal to negative 40. Now we can divide by negative 20 both sides, and we end up with x is equal to 2. So therefore, 2 hours. But it asks us how far from Ottawa does the second car overtake the first. So therefore, we will just put that into our formula of D equals RT. So rate is 60 kilometers per hour multiplied by the time, which is 2 hours, which gives us 120 kilometers. So the final answer would be how far from Ottawa does the second car overtake the first? It would travel 120 kilometers to catch up to the first car. Catch up to the first car. All right, so just keep in mind again what is the question asking, and make sure the final answer just does answer the question from the problem. All right, second example, we have Turtle Terry leaves Regina at 10 a.m. and averages 40 kilometers per hour. At 12:30 p.m., Hot Rod Harvey leaves Regina and catches up to Turtle at 2:30 p.m. What was Hot Rod's speed? All right, so here we have to take the time into consideration because this is between 10 to 2:30, which will be 4.5 hours. And then this here, 12:30 to 2:30, which is the 2 hours. All right, so that is how we've gotten our time. 4.5 hours for the Turtle Terry, and then 2 hours for Hot Rod Harvey. All right, so again, dA is equal to dB. So dA is going to be 2 times x, and then that's equal to 40 times 5. And then we have 2x is equal to 180, divide by 2, and we have x is equal to 90. All right, so the speed, what was Hot Rod's speed? So Hot Rod's speed is x, which is what we just solved for. So Hot Rod Harvey was traveling at 90 kilometers per hour. Okay, just note the units for the rate is in kilometers per hour. Okay, so next one for you guys to try. Terry leaves his house riding a bike at 20 kilometers per hour. Sally leaves 6 hours later on a scooter to catch up with him, traveling at 80 kilometers per hour. How long will it take her to catch up with him? So I'll give you guys a moment to try this. We already have the rate and times filled in. The scooter is going 80 kilometers per hour, and the bike's going 20 kilometers per hour. So Terry is t, and then Sally is t minus 6 hours. So distance is rate times time. We're just going to multiply those. So the equation is already set up here. You just have to solve for t. Solving for this one here, we've already have the chart that's set up for us. So we just have to solve for t here. So 20t is equal to 80t minus 480. We'll subtract 80t both sides, which gives me negative 60t is equal to negative 480. And then we'll divide by 60 both sides, which gives me t equals 8. All right, so go back to our original expressions there. So Terry would be 8 hours, Sally would be 8 minus 6 hours. So she needs 2 hours to catch up to him. All right, so this is where we will stop.